Two more examples of solving absolute value equations. So we've done these first three and experienced some success, learned quite a bit. What if we have something like this, absolute value of 3x plus 8, and we can continue to make these more and more complex, all right? But it's important to remember the basics. When is it that I need to think critically about absolute value? Well, not yet. I need to go ahead and subtract 8 from both sides and have that absolute value. I like to have that absolute value expression by itself because then I can really think about absolute value. All right, so 5x minus 8. All right, now I have the absolute value of an expression is equal to another expression, and that's fine. All right, so I'm going to say, well, 3x plus 8 could have a value of exactly 5x minus 8 and solve that equation. Or that expression 3x plus 8 could have a value of, wait for it, negative 5x minus 8 quantity. All right, because I'm going to negate everything about that equation. So here we go. To solve this equation, I'm going to subtract 3x from both sides. So 8 equals 2x minus 8. I'm going to add 8 to both sides. So I have 16 equals 2x. So 16, so divide both sides by 2. So 8 equals my x value, 8. All right, next one. I have 3x plus 8 equals negative 5x plus 8. So that's a little weird. Plus 8 on both sides cancels out. I could subtract it and they're going to cancel out. So I have basically 3x equals negative 5x. All right, it's a little odd. I'm going to add 5x to both sides. So I get 8x equals 0. So x must be equal to 0. All right, once again, I'm going to try to substitute both of these to see if they work out. So let's check the first one. X equals 8. 3 times 8, 24. 24 plus 8 is 32. Absolute value of 32 is 32. 32 plus 8, 40. And then substitute 8 on the right side. 5 times 8, 40 again. Works out. All right, so looks like our first answer is worth it. Let's try 0. 3 times 0, 0 plus 8 is 8. Absolute value of 8 is 8. 8 plus 8, 16. So I get 16 right here on the right side. 5 times 0 is 0. 16 is not equal to 0. So we have encountered an extraneous solution. X equals 0 does not work. All right, so our answer is x equals 8. Now, what if we get to a quadratic? I probably won't get to the end of this problem before our 5 minutes are up. So let's just set it up. X squared, absolute value of x squared minus 4x minus 5 equals 7. That means, well, we've got the absolute value. We can go ahead and say that the expression could be equal to 7, or the expression could be equal to negative 7. And in both of these cases, well, it's a quadratic equation, so I'm going to set it equal to 0. X squared minus 4x, negative 5 minus 7 equals negative 12. And in this case, negative 5 plus 7 gives me plus 2. All right, let's see. Add 7 to negative 5. I get plus 2 equals 0. All right, so we're going to try to solve these. Let's see if this one will. How much time do we have left right here? Okay, so because we have a quadratic, we need to recall that there are many ways to solve a quadratic. We got factoring, there's graphing, which actually we're going to get to graphing in a separate lesson. Many different ways. So with both of my quadratic equations, I have different ways to solve it. In this first quadratic equation, I see that I can actually factor the expression. So I factored it and then found the zeros. So x equals 6 and x equals negative 2. I did it just real quick, right? With the second one, I cannot factor x squared minus 4x plus 2. So what I did is I used the quadratic formula, which, long story short, I ended up getting that x equals 2 plus or minus the square root of 2. Kind of complex. So we can continue making these just more and more complex. But again, the gist is the absolute value of an expression is equal to positive or negative. And that's basically it. We can make the problems complex, but that's okay. That's the lesson.